A lot of times when we're dealing with circular motion, we actually have another thing going on as well. It's called periodic motion. Now, periodic motion just means the motion repeats. So when we have something that happens over and over again, like going in a circle, we have periodic motion. And period is the amount of time required for one complete revolution. And if we know the period, that amount of time, we can use that to find centripetal acceleration, as long as we also know the radius. Because if we know the time for one complete revolution, the period, which is so important it gets its own special abbreviation, capital T. Usually we use lowercase t for time. Well, when we're talking about the specific period of something, we use capital T. All right, so if we know the period and we know the radius, we should be able to calculate the centripetal acceleration, because centripetal acceleration equals v squared over r. But remember, v is velocity, and velocity is displacement over time. And if we know the time it takes for one revolution, then we also know how far it's gone, right? One revolution means it goes all the way around and ends up back where it started. So the distance it's covered is actually equal to the circumference. Well, circumference is equal to twice pi times the radius. So if I use that for my distance, and I know the time is the period t, then I can substitute this into my equation for velocity, and I get 2 pi r over t equals velocity. Then I can put this into my centripetal acceleration formula over here, and we can actually get a centripetal acceleration that depends on period instead of on velocity. So what we get is centripetal acceleration equals v squared over r, but v squared is 2 pi r over t squared divided by r. So now if I run that square through the parentheses, 2 squared is 4, pi squared is pi squared, r squared is r squared, and t squared is t squared, times, remember dividing by something is the same as multiplying by the fraction, times 1 over r. Well, this r cancels that square, and this simplifies to 4 pi squared r over t squared. And so my centripetal acceleration can be simplified by this. AC equals 4 pi squared r over t squared. So that's handy if we're given the period and the radius of something. We don't actually have to stop and calculate the velocity. We can just go ahead and throw it into this formula. Similarly, we have this other thing called frequency. Okay? Now, frequency tells me how often something occurs. Let's go back to period for a minute. Period was the amount of time required for one revolution. So I'm going to write it like this. Time per revolution. Okay. Frequency is revolutions per time. Okay. So these two things are inverses of each other. The symbol for frequency is lowercase f. Remember, the symbol for t, or for period, is capital T. Now, these two things are very closely related. If you look, it turns out that t is identically 1 over f, or if you'd like, you could say f is 1 over t. Those are the same thing. Now, a lot of times you're given frequency, and frequency is usually given to you in revolutions per second. Say, like a record player has a frequency of 45 revolutions, and this is actually revolutions per minute. Okay? And if I know the radius of the record, I can find all kinds of things about it. I want to know its centripetal acceleration, whatever. Well, how can I use frequency in my equation? And is that okay? How are these two things going to work? Well, because frequency and period are related the way they are, we can actually go back to our equation. Centripetal acceleration equals 4 pi squared r over t squared, but we can replace t with 1 over f. Okay? So this is the same thing as 4 pi squared r over 1 over f quantity squared. And remember, when you divide by a fraction, it's invert and multiply. So this is 4 pi squared r f squared. Okay? So if I know the frequency or I know the period, I can actually come up with the centripetal acceleration of the object. So